All right, so this is a follow-up to what I did yesterday, which was I reworked the pathfinding to be solved. Basically, each agent no longer paths for themselves, but they now are just making decisions based on where they are, right? And they don't know anything besides where they are. And so that simplified a lot of the calculations per agent. And so what I wanted to do next to be able to support an extreme number of agents was I wanted to be able to essentially uh, no longer rely on what Unity does, at least in the non-dot system, right? I didn't want to convert my whole game to dots. And so I'm emulating a dots-like ECS structure within a non-dots Unity project, right? So the way typical Unity does, they have, a game object, object, and that object can have, n components. And each of these components then has like their, awake, they have a transform, they have update, etc. Right? They have all these native Unity things that they do to automatically manage it, right? And so, for example, the transform component has a bunch of native calls for getting position, setting position, translating, etc. The sprite renderer component has a bunch of, graphics calls to the renderer, and it creates, its vertices, its UVs, and whatnot with the material and texture you give it, right? And so every one of these agents was then, at least for my game, they were a transform, they were a sprite renderer, and then they were a agent, right? And so the agent is its own mono behavior, right? And so that's, for every single game tick, that's three at least updates, right? And that's also three or a render call, a bunch of native calls for moving every time I move anything. And so what I did was when I was profiling, I noticed that what was keeping me down when I had 10,000 agents was just native calls, right? It was just calling to transform, it was calling to the render, right? So what I wanted to do was do what ECSs do, which is you don't have mono behaviors anymore for certain things. At least in the ECS, there are no mono behaviors at all. But in my game, I wanted to turn agents from a mono behavior to just a set of data, So the agent becomes an entity, so to speak. An entity has components. The components are just structs of data. And then there are systems that pick up that data, right? Or I guess there are systems that pick it up, right? So what I did was something like this, right? So the agent isn't really an entity. There's no entities, right? But I do have an agent data struct, right? And there's a bunch of data in there that I'll show. And then I have a bunch of systems, right? There's the agent system. But under that system is the render system. There's the processing system that does all the steps for each agent, decides where they're moving. There's the there's one more. I guess I'll just check what it is. Oh yeah, there's the physics, right? The hit detection system. And so each of these systems manages what this agent data does per step, right? And so you end up getting a huge reduction in these native system calls, right? Which ends up speeding things up massively, right? And so I'll show off a little bit of what that looks like. First, I'll show off what the agent looks like. There will be more states than this for now, but they're pretty simple. Eventually, I just had a test tower yesterday to make sure this stuff works. And so that's why I wrote the physics for it, right? But you see here that agents just kind of have, well, these are helper methods, right? But they just have a bunch of data. And the reason I'm doing this instead of some vector3 ints is there's a lot of overhead. And not a lot, but like when you have 10,000 things running computations, there's overhead on using vector3 and vector3 int computations. There's like, safety and whatnot. So this keeps it a little more cache local and whatnot. So it's like marginally faster on like a fraction of a second per agent. But then with 10,000, maybe even 20,000 agents, it is significantly faster. And by significantly, I mean maybe 20 FPS. Anyways, so you see here that there's a lot of things going on here. You have the state they're in, and that's what the processor uses to know how to make it behave for that, that frame. There is, all these stats they have, where they are, where they're going, where they are in the queue of agents, their health, their position, their height. That's for physics. And so all these fields, right? This is all the agents are, right? And so the agent system, rather than spawning or instantiating a mono behavior with components on it, it simply creates this struct, right? And it creates it with very little data. And then when you start it, you pull out that struct, you modify it, and then you send it back, right? Okay, and so everything else works pretty similar for the agent service, right? But then I had to break out some things, right? Because in the old way, the agents processed themselves. They had their updates and their starts and whatnot. But now I needed to write a processor that does all that updates for them. So you pass it an agent, it steps it. Eventually, I'll get rid of this ref. I think I'll probably end up just having a get and a set, right? Either way, you see here that, based on that state that the agent has in its structured data, I have a bunch of functions, right? So this one is the one that moves it to its goal position. I have one that when it's at a goal position, it sets the next goal, if there is one. If not, it sets it to the at crystal state. And then within at crystal, eventually there'll be, instead of just releasing it immediately, there will be like an attack, right? They'll attack the crystal, they'll do damage to it. That'll repeat. There's the death state that I haven't put in yet, but there will be one of those, et cetera, right? So there's a lot of things, that haven't been made yet. But all this processing here means that I'm doing very local data changes as opposed to calling natively in the Unity engine, get position, set position, whatnot on those transform components. And then I have one batched renderer, right? And so this renderer, it has a, generic, it's creating a mesh every frame, right? It has a, let me zoom in so it's a little more legible. I guess I could have done it for the previous one, but it's creating this mesh, right? Every single frame, it clears the mesh. It adds each agent to that mesh based on its, right now this is all static, right? And same with the sprite. Eventually the sprite will come in through like an agent animator thing that I'll have to set up for each agent type. But this is essentially kind of how ECS renderers work, right? Where I create a render mesh for this entire system, and then I render that singular mesh one time. So it's one draw call as opposed to 10,000 draw calls. And so the performance increase is massive. I think, let me make sure I'm spawning enough agents to where it's noticeable. Yeah, I have 10,000 agents spawning rather quickly. And you'll notice that if you remember from the previous log, and this one will be pretty quick, I'm actually probably done here shortly. The FPS here, of course, there's other things going on, right? But it's about 100 FPS faster for 10,000, right? And you get these. I mean, they're honestly a little ugly, right? Because I just have no art for these yet. But you can see that there's just so much happening here. There are so many per these piles. And so I have some way of checking how many per square there are. It's about 50 per square when it's this dense, maybe even like 100, because I'm quantizing them per hit detection in physics and whatnot. But the point is that this is seamless, and I would go record a test on my really bad laptop to make sure the performance was good still, but that's just how it is for now, that I won't have that clip for this. But the point that I'm making with this log is that when you're doing really high performance things, and ECS structure is great, you don't have to, like many people who are wanting or talking about it, you don't have to swap over to a dot structure. You don't have to, create jobs, schedule jobs. You don't have to convert your entire game to eke performance out like that. You can convert just small sections of your game, right? I have an agent system that handles everything to do with this huge blot of agents, and that is all it is, right? There's nothing else going on, and so you can save huge performance without actually converting your whole game over. And so, if you're making a simulation game for any reason, RTS or a Factorio-like game, and you're having to simulate thousands and thousands of things, maybe it's even just a bullet hell game, right? Maybe don't make your bullets model behaviors. Maybe just make them data, right? And then you can render all those bullets using tricks like I have just there, where I am each frame, I add a bullet to a draw list, I draw it, I render that single draw list one time. And you'll be able to see massive performance benefits. Of course, in a bullet hell, you probably realistically just delete or pool the bullets and you don't need to do all this. But it can help, especially if you're trying to, keep things fast for people with worse performance laptops, right? And that's what my goal is that I want to be able to test this game on my bad laptop and make sure it runs really well. And so when I last tested it without both the flow graph and now this, I was getting 30 FPS or so with 1,000 agents. Maybe it was even less than that, I don't remember. But now I can, last I tested it, my laptop's dead for now, but with this yesterday, I was getting, hundreds of FPS, 150 or so. And so, it's not always worth it if you're, on a tight deadline or working for a real team, but it can be if you want to do it for fun, or if you want to just, make your game as high quality as it possibly can. You can get this smooth of recomputation, right? See, all these agents are recomputing their paths instantly. Well, they don't even have their own path anymore, but with 10,000 agents, I'm moving all these things and you see like no slowdown, right? And it's beautiful to me. I don't know. I like it. I'm big in engineering. Okay. Now that this is done, I've been starting to work on towers again. And so the next thing I demonstrate will probably be animating these agents. And I'll also have like more states for them, right? So like I'll probably kill them or something, and you can see how this horde will work. Another thing I want to do is right now the way the horde works is they sort of pick a random spot around where they're heading to make it look like they're spreading out, but I want to make them repel each other slightly within the bounds of the level they're in. And so that will, I don't know how that'll work, but something that I want to look into. So yeah, anyways, appreciate it. This one's a quick one. Well, I guess as quick as it could be. I tend to yap, but appreciate it. Next time, something interesting to show off, hopefully. Last boring video, I think. Bye-bye.